So today we're going to start with chapter 2. So this chapter is about factors and multiples. These are the two main characters we're going to talk about in this chapter. Okay. So to be simple, factors of a whole number are the numbers that can divide the whole number exactly. Multiple of a whole number is the number which is the product of itself with another number. So for factors, let's say 3 is a factor of 12. So it means that 12 can be divided by 3. 3 can divide 12 exactly. Okay? So 12 divided by 3 is 4. This is what we call can be divided exactly. Okay? So 12 can be divided by 3, that is 4. Right? How about multiple? Multiple is like, if we say the multiple of 12, that's 12 times 1 equals 12. So 12 is a multiple of itself. And then 12 times 2, that's 24. So 24 is a multiple of itself. 24 is a multiple of 12. So that is 12 times 2 equals to 24. So multiple of a whole number, 12, is the number which is the product of itself, which is 12, with another number, let's say 2 in this case, that is 24. So that's multiple, okay? Easy. So that's factor and multiple. So now we're going to focus on factor and look at common factors and highest common factor, yes. And then we have multiples, common multiples, and then we have lowest common one, right? Alright, factors. So just now we said that the factor is, let's say, a factor of a number is the number that can divide that number exactly. So let's say in this case, we're going to list all the factors of 18. So we need to determine what number can divide 18 exactly. Okay. So this one, we always start from number 1. And then we will proceed until we can't proceed anymore. Okay? So start from number 1 times how much gives you 18. That is 18. Okay? So if you can write things like this out, it means 1 and 18 are the factors of 18. Right? Because 18 can be divided by 1, then 1 is a factor. 18 can be divided by 18, 18 is the factor as well. Okay? So we're going to determine more. We need to list all of them out. So now, after 1, let's check for 2. Can 18 be divided by 2? Use the calculator to check. Okay? 18 divided by 2, if the answer is not in fractions or decimals, is a whole number, yes. The answer is yes. Okay? So, 2 times what gives you 18. When you press the calculator, check on the calculator, 18 divided by 2, it gives you an answer, right? An answer. The answer is whole number, yes, it can be divided, and the answer will be this one. So that's the 2 and 9 are the factors of 18 as well. Let's proceed. 3. Can 18 be divided by 3? Yes. 18 divided by 3 is 6. So 3 times 6 is 18. Okay, let's proceed. 4. Can 18 be divided by 4? Proceed on your calculator. No, the answer is no. It cannot be divided. There is decimals, right? And let's proceed to 5. Can 18 be divided by 5? Exactly, no. And 6, yes. So 6 will be times 3 equals to 18. Alright. This one is repeated here. Okay? When you do this list, when the next number appears in here already, then that's where you stop the list. You got everything already. Okay? Because if you're going to continue 6 times 3 equals to 18, then you try 7, 8, and then 9, yes. So then you write 9 times 2, that gives you 18. See, this is repeated. Okay? And then I guarantee you the next one you got after 9 is 18. That's repeated. Okay? So you can just stop here And these are the factors, all of the factors of 18. So you just need to answer the questions by writing down factors of 18 are 1, 2, 3, 6, 9, and 18. Okay, so that's it. Next, for prime factors is the factors that are also a prime number. Okay, so let's use the same case. List all the factors of 18. They are 1, 2, 3, 6, 9, and 18. And then from this list, we're going to list out the prime factors. So how do you check for prime factors? If you memorize it from primary 6, yes, that will do. But this is how I do it. Prime factors, I don't memorize this number in my head. Okay, just need to check whether this number can be divided by something, some other number else. Okay, some other number. So except 1. For prime number, we doesn't include 1. So the first number you're going to start from is 2. Okay, 2 only can be divided by itself. 3 as well. And then 4 now, 5, yes. Okay, so that's how you check it. So from this list, 1 is out, is not a prime number. We don't say 1 is a prime number, even though I know 1 cannot be divided by something else. Yeah, anyway, we start from 2. So 2 is a prime factor, yes. 3, yes. 6, no. So 6, no. Because 6 can be divided by 2 and 3. 9 can be divided by 3. So no. 18 can be divided by 1, 2, 3, 6, 9, and 18. Okay, so 18 definitely is not a prime factor of 18. Okay, so the prime factors of 18 are only 2 and 3. Alright, next we're going to see prime factorization. So question, express 84 in the form of prime factorization. So this is like 3 branching. So we're just splitting 84 into small numbers until we cannot divide further. Right? So let's start with 84 on top, and we're going to split it into 2 numbers. It means what times what gives you 84. You can just randomly choose a number and then press on the calculator. 84 divided by the number that you have chosen and give you a whole number. Then you can pick that pair. Okay, just press the number that you just write down the number you have chosen here and the answer here. So just pick a random number. Let's say I pick 4. So 84 divided by 4, that is 21. Okay, so it means 4 times 21 gives me 84. So 84 divided by 4 is 21. 84 divided by 21 is 4. That's how you write it. Okay, so we split it into 2 numbers. So let's split further for 4 and 21. So let's split 4 first. It becomes 2 times 2. Try not to write 1 and 4, like 1 and 21. No, we are not splitting it. It's not splitting. Okay, we're going to split it into small number. So never ever write 1. Okay, so 4 we can split it into 2 times 2. 21 we can split it into 3 times 7. Can we split further? 2 split further? No. So actually you can realize that these numbers cannot split further, means they are prime numbers. Okay, so this is what we call prime factorizations. These are all the prime factors for 84. The final answer, just write this is therefore, or hence, like dot, just hence, in conclusion, something like that, right? That's for maths. So therefore, 84 equals to 2 times 2 times 3 times 7. Okay, that's it. So that's how we use the method for prime factorization. Actually, we call this a factor tree. Okay, there is another method to do this one, which is just divide 84 repeatedly by a chosen number. Okay, but actually the theory works similar to this one, just a different way of presenting it. So let's check on that method. So for the same question, express 84 in the form of prime factorization, just like how we're going to answer, just like how we answered just now, 84 equals to 2 times 2 times 3 times 7. That's the prime factorization form, okay? So just now we already see factor tree method. Now we're going to see the repeated division method. So we start from 84 definitely, and we're going to divide this by, you choose a number. Just now I used 4, right? Let's try a small number. Let's say you don't really know what number you can choose. 84 is an even number. The easiest for even number is to choose 2. Because all even numbers can be divided by 2. Okay? So 84 divided by 2, that is 42. And 42 again is an even number. You can further divide by 2. That is 21. 21 can be divided by 3 or 7. Let's try 7. Then it gives us 3. And then we just need to keep dividing until it becomes 1. Alright, that's where we stop. Then 3 can be divided by 3, and that is 1. So 84 answer, 84 equals to 2 times 2 times 3 times 7. That's it. Okay, I'm back. So again, we're going to continue with common factors. So this one is about comparing between 2 numbers or more. Okay, we can do 3 or 4 or more. So this one, let's start with just 2. Okay, so list all common factors of 18 and 32. So for this one, basically we just need to list out all the factors for 18 and all the factors for 32, and then find a common one, that is the factors that are shared between 18 and 32. Okay, let's start. So let's list the factors of. Okay, just now we've done this. This one, the factors were 1, 2, 3, 6, 9, and 18. Okay, and then the factors of 32. Let's start with 1. So 1 times 32 is 32. 2, 32 divided by 2. Okay. Factors of 32, 1, and then 2, yes, 32 divided by 2 is 16, so later on we're going to put 16 over there, and then 3, can I do divided by 3? No, 4, yes, 4 times 8, 4 times 8 is 32, and then 5, nah, 6, nah, 7, no, next one is 8. So that one is with the 4. So we actually end the list already. And then 16 and 32. Okay, so that's it. That's the factors for 32. So now let's compare between the factors of 18 and factors of 32. So look for the common one. So the common one is 1, 2, and that's it. So the common factors for of 8 and 32 are 1 and 2. Next, we're going to look at highest common factor. Short form HCF. HCF. Highest common factor. Okay, so as the name suggested, the highest common factor for 18 and 32 is the common factors which has the biggest number. Okay, so we already identified the common factors of 18 and 32 are 1 and 2. So out of 1 and 2, which one is biggest? That is 2. So the highest common factor of 18 and 32 is 2. Find the highest common factor of 24, 48, and 60. So, one way that you have seen just now is to list out the factors for 24 and 48 and 60. Okay, list out all the factors and then choose the common ones. Alright, but that one is way too long, wasting time, take a long time. So let's learn a quick way to do this. So this only works for highest common factor, okay? Later on, we're going to use similar method to find the lowest common multiples, but there's a little bit different here, okay? So let's look for the highest common factor first. So let's write down 3 numbers together in a row. Okay, then we do division. Okay, let's try to divide all 3 of them by the same number. So let's say we can divide them by 4. Okay, if you think, how do I divide 60 by 4? You can choose a small number like 2. Okay, this is up to you. So I can choose 4 because I know how to do the calculation. So 24 divided by 4 is 6. 48 divided by 4 is 12. 60 divided by 4 is 15. Now let's go ahead and divide all 3 of them until we cannot divide further. Okay? So 6, 12, and 15, we can divide all 3 of them by 3. So 6 divided by 3 is 2. 12 divided by 3 is 4. 15 divided by 3 is 5. Okay, now 2 and 4 can both divide by 2, but not together with 5. Okay? Actually, 5 is a prime number. It cannot be divided by any other number except itself. So, and 2 and 4 cannot be divided by 5. So that's it. We cannot divide further. So we stop here. Okay? So then, now let's write down the HCF of 24, 48, and 60 is this times this. 4 times 3, that is 12. So the highest common factor, let's write down. Therefore, the highest common factor of 24, 48, and 60 is 12. You can use the other method to list out all the factors of 24, 48, and 60, and then you're going to see that 12 is the highest common factor. Yeah, you can try it out yourself. I'm not doing it. Alright, next, multiples. So, like, remember what we said earlier? Factors is the number that can divide a whole number. Okay? So let's say 3 is a factor of 12, then 3 can divide 12 exactly. That's a factor. 3 is a factor of 12. Now this is the multiples. So like, the reverse, we can use the reverse. 12 is a multiple of 3. So it means that 3 times 4 is 12. So 12 is a multiple of 3. Okay? So now we're going to look at the multiples. Let's list first 5 multiples of 8. Because for multiples, it's not like factors. We have a limit number of factors for a number. These multiples, you can go forever because let's say for 8, the multiples of 8 is like 8 times 1, that's 8. 8 is the first multiple. 8 times 2, 16. 8 times 3, 8 times 4, times 5, times 6, times 7, times 8, until infinity. Times a million, billion, yeah, so it's infinity list. So usually the question asks you to list down like the first few multiples of a number. Not everything, okay? So let's do this question. List the first 5 multiples of 8. So let's do it quick. Let's just write down, okay? So the first multiple of 8 is just 8 times 1, that's 8. Then the second multiple is 8 times 2, that's 16. And then 24, 8 times 4 is 32, 8 times 5, 40. That's the first 5 multiples of 8, that's it. Okay? Now let's do the common multiples. List the first 5 multiples of 6, 9, and 12. So let's start with the multiples of 6. So the first multiple for 6 is 6 times 1, 6, 6 times 2, 12, times 3, 4, times 5, times 6, let's go longer, times 7, times 8, times 9. Okay. Now for 9, let's do until 8 or so. So 9 times 1, 9, times 2, 18, times 7, times 4, 36, times 5, 45, times 6, 54, times 7, times 8. Okay, for 12, 12 times 1, 12 times 2, 24, times 3, 36, times 4, 48, times 5, 60, times 7, 84, times 8, 96, times 9, 1, and this one. Okay, so let's look for the first common multiple. Oh, my question, there's something wrong. Write at least the first 5 common multiples. Sorry, I didn't notice about that. Should be common multiples. Okay, so let's identify the common multiples between them. Let's start from 6. There's no 6, 12. There's no here, but not here now. 18 here, but not in here. 24 here, but not here. 36. That's the first common multiple. Okay, and then we need to go further. Can we get the second one? No. I think the next one will be 72. Isn't it? Is it not? Wait. Let me extend this further. That will be. Oh. Yeah, 72. So that's the next one. So the first 5 common multiples we already get 2. The first one is 32, 36, the second one is 72. If you want to get the third one, fourth, and the fifth one, can you see how long you can write? No, I'm not doing that. So when you got the list around, actually you can stop the list around here. Yeah, around here. You can stop already when you see the common multiples. Of course, you need to practice to be able to know like when you're going to stop. You need to get familiar with the numbers. Anyway, you can do like me, go up until 9 or 8. And if you can't see any common multiples, you extend again. Okay? Yeah, that's another way you can do it. So here, this one we already identified the first common multiple. Okay, they need 5. So this is the trick. Once you got the first common multiple, we can write it down. So therefore, the first 5 common multiples of 6, 9, and 12 are, the first one is 36. Okay? Then the next common multiple will be the multiples of 36 actually. So you can check 72 is actually 36 times 2. Okay. So the second one is 36 times 2, that's 72. And then the third one times 3, that will be 108. And then times 4, and then times 5. Let me check if that's right. Yes. Alright, so that's how you list the first 5 common multiples of 6, 9, and 12. So the trick is just to find the first common multiple by listing all of them and then look for the common ones, and then do the multiples of the common multiples that you have identified. That's it. If they ask for 10, if they ask for first 10 common multiples of these 3 numbers, just do the 10 multiples of 36, that's it. Okay? Nothing wrong. Alright. So now we're moving to the last part. Alright. Lowest common multiple. So I'm using the same question from just now, just that we need to identify the lowest common multiple from the common multiples we got just now. Alright. So as the name suggested, this is looking for the smallest number among all those common multiples. Okay? So we're looking for the lowest common multiples of 6, 9, and 12. Okay, so just now we already identified the first 5 common multiples of 6, 9, and 12 are 36, 72, blah blah blah. I can't remember. So the first one is the smallest number, right? 36. So that's the lowest common multiple. So that's the first method you can use to identify the lowest common multiple. So list out the multiples of 6, that's 6, 12, blah blah, and then the multiples of 9, 9, 18, 27, blah blah blah. Then I'll give that one to you. And then multiples of 12. And then you identify 36, 36, and 36. That's the first common multiple. So the lowest common multiple of 6, 9, and 12 is 36. That's it. Okay? So this method works. Just that we have other methods. So let's start off. We're going to use the method that you have seen for HCF. Okay? So 6, 9, 10. Then we divide it. So this is repeated division. Okay? So the difference, just now I said, it's the HCF and LCM for the same method is a bit different, right? HCF we don't divide We divide until we cannot divide all three numbers by the same number. We stop there, okay? But for LCM, we divide until all three of them becomes 1. We finish the division until all of them becomes 1. Finish the division. Divide regardless, okay? So let's divide them by 3. So this one, 6 divided by 3 is 2, 9 divided by 3 is 3, 12 divided by 3 is 4. Let's divide further. So if this is HCF, we stop right here. 3 is the HCF of 6, 9, and 12. But for LCM, we continue ahead. We stop here for HCF because 3 cannot be divided by 2. 4 and 2 can be divided by 2, but not 3. Okay, that's where we stop. And now LCM, we continue. So let's divide 2 so that 2 and 4 can become smaller. So 2, this one becomes 1. This one we don't divide right, so copy down. And then 4 divided by 2, that's 2. Okay? So this one already becomes 1. Mission complete for this one. So we need to focus on these two to make them become 1. Okay? Let's go ahead with 3. This one no more, so just copy down 1. 3 divided by 3 is 1. 2 we cannot divide by 3, so just copy down. So second one is done. Let's go for the last one. Divided by 2. 1, 1, 1. That's what we want for LCM. We want to get all three of them becomes 1. Okay, that's how we finish the division. Once we've got this, then we can times them up. So the LCM of 6, 9, and 12 is 3 times 2 times 3 times 2, and that is 36. So now let's look at the third method, prime factorization. So as the name suggested, prime factorization, we're going to split 6 into the prime factorization form, and then 9, and then 12, okay? And then we combine the common ones. And let's do it. So let's split 6. So for prime factorization, how you do it? We split 6 into 2 times 3. Can we split 2 and 3 further? Now that's it. So write down 2 times 3. Okay? Now go for 9. 9, we can split it into 3 times 3. Cannot split further, so that's it. So for this one, let's align the same number together. So 3, so there's 3 here, it is 2, so this space has to be for 2. For 9, it is 3 times 3, there is no 2, so I skip the space, and then I start the 3 here. And then there's another 3, put here. Okay? And then 12, we can split it into 2 times 6, and then 6 you can further split it into 2 times 3. So 12 is 2, because there is 2 here, so I write underneath, times another 2. Or let's times the 3 here, because there is 3 here. And then times a 2, but this is a 3, so I write further backwards. So times 2, okay? So this is 12, 2 times 3 times 2. Alright, so now let's look for the... Oh, my bad, it's not looking for the common ones. This is how you do it. So after you got all this, let's combine the common ones. So this one is the same as this one. We just write down 2. Rather than write 2 times 2 times 3 times 3 times 3 times 3 times 2. Now, this becomes 1. Okay? So we go like this. So there is 2 here, and this one is 3, so times 3, and this one is 3, and this is 2. So the LCM of 6, 9, 12 is 2 times 3 times 3 times 2. That is 2 times 3 is 6, 2, 3 times 2 is 6, 6 times 6 is 36. So same as the answer just now, just a different method. This is prime factorization. So I repeat again, you split them using the prime factorization method, and then write it down. So just now the 6 was 2 times 3, so you write it down first, okay? And then 9 is 3 times 3, then you arrange them. There's a 3 here, so put the 3 here, the first 3 here underneath, okay? Then there's another 3. There is no more number here, right? So just add it back, okay? And then 12 is 2 times 3. So 2, there's 2 here, so right underneath, and then there's a 3 here, so write 3 here. And then there's no more space for the 2, so go for the 4th column. Okay, that's how you do it. And then for the final answer, just write, this is 2 column, this is the column for 3, so write number 3, this is the column for 3, and this is the column for 2. That's it. And then times up all the numbers, and then you get the LCM. So we are basically done for this chapter. I think I should give you another question on the LCM and then HCF to practice on the repeated division method. Okay? Now, the very final question from me. The very final practice from me to explain how to do these kind of questions. Okay? I actually combine the questions for LCM and HCF. So let's look for the LCM first. Now, let's look for the HCF first, and then we're going to determine the LCM for 24, 26, and 64. So let's determine the HCF for all these 3. Okay? So let's divide them until we cannot divide further. Means all 3 of them cannot be divided the same number anymore. Okay, that's where we stop. So 24, 36, 64, let's divide. If you cannot think of a number, just try 2, because all 3 of them are even numbers. So let's try 2. So 24 divided by 2 is 12, this one is 18, this one is 32. Yes, let's divide further. Can still use 2, yeah, let's do it slowly. Okay, so 12 divided by 2 is 6, this one divided by 2 is 9, this one divided by 2 is 60. Do it further. No. That's it. That's it. So that's it. 6, 9, and 16 cannot divide further by any number except 1. We don't include 1, okay? So that's where we stop for HCF. So the HCF of 24, 36, and 64 is 2 times 2, that is 4. Okay? You can use other method to check whether this answer is correct or not. Now, the last part of this video, determine the lowest common multiple of 24, 36, and 64. Okay, so for this one, we need to divide it until all of them becomes 1. Okay, so let's do the same thing. 2, this one becomes 12, 18, 32, and then divide again by 2. This one becomes 6, 9, 16, and then we can divide 6 and 9 by 3. This one becomes 2. 6 divided by 3 is 2. 9 divided by 3 is 3. 16 cannot be divided by 3, so just copy down. And then I'm going to divide these 2. 2 becomes 1. 2 divided by 2 is 1. 3 cannot be divided by 2, so copy down. 16 divided by 2 is 8. Next, divide 3. 1. 1. This one cannot be divided by 3, so it becomes 8. And then 21 divided by 8, we get 1. Okay, that's right now. So the LCM is 2 times 2 times 3 times 2 times 3 times 8. Not times 8. Okay, so the answer is 2 times 2 is 4, 4 times 3 is 12, 12 times 2 is 34 times 3. We just use calculator. That's 1. Okay, let me double check the answer. 2 times 2 times 3 times 2 times 8. That is, yes, 576. Okay. The answer is 576. Alright, we are done for today. This is chapter 2, and good luck for your homework exercise and exercise.